All right, guys, STAT2500 had a couple of people inquire about some of the solutions. Ideally, ask this stuff in class. It makes it a lot easier because chances are if you don't understand it, someone else doesn't either. I guess it's my job, so that's why I'm putting up this study guide. So, I'm sorry, putting up the solutions to the study guide. So I hope it helps. So I'll go through and work all of the 12 problems. So guys, the first problem, basketball player competed, and you see it there, right? This works all about sums, and if you remember for number one, well, in general, that the mean is just the sum of the x's divided by n. So, for example, when they've competed, this person has competed in 8 games and averaged 11 points. So their average is 11. Their average is 8. Their average is 11. They've competed in 8 games, so the sum of the x's can be found easily by just cross multiplying. So the sum of the scores would be 88. Now, how many points would they need to score in the next game to raise his or her average to 12 points per game? Well, we know a 12 would be there. The sum of the x's, we know that 1 game more is 9 games. So the sum of the x's here would be 108. So guys, all you have to do is take the sum of the scores after 9 games minus the sum of the scores after 8 games. So they would have to score 20 points to raise their average by 1 point. Number 2, a professor has 28 students in his class. He reported an average on the first exam is 80.2. With n equal 28, so using kind of the same logic we have up here, the sum of the scores would have to be 28 times 80.2. Let me grab my handy dandy calculator here. 28 times 80.2. So we know the sum of the scores. Having a hard time getting going this morning, guys. So the sum of the scores would be 2245.6. Now, the bonehead professor made a mistake. Imagine that. Accidentally record a score of 91 as 19. So that means that the sum is overinflated by 91 minus 19 points. So that would be 72 points. So guys, we need to correct the overall sum by 72. So that's 2173.6. Divide that by 28. Well, guys, we're having a cat fight back here. I don't know if y'all can hear that or not. So the new average would be 77.6. All right, that doesn't seem right, is it? Yeah, it is right. All right, the third one. I'm not even going to work this one. I worked it in class. Guys, just follow the lines over, make an approximation as closely as possible. IQR is just the difference between Q3 and Q1. I'm not going to spend any time on that one because that's something that we should all know how to do. If this were a multiple choice question, for example, like right here, when you follow that over, I called that about 610 or something like that. I don't know, 605. This person called it 605. I called it 610. Probably 605 is closer. No, I think I actually called it 600. Anyway, the correct answer there, I wouldn't have like 600, 605, and 610 as three things that you could select from in the multiple choice. I would have something like 500, 600, and 820. So it would be clear if you didn't get it right. It wouldn't be because you estimated differently than me. It would be something different than that. All right. SAT scores, 5 students. Well, guys, what I'm going to do there is I am going to, you can see I'm having problems with my TV. So let's go to my stat lab. Maybe. I live kind of in a rural, I don't live in kind of a rural area. I live in a very rural area. My internet connection is absolutely horrible. On Saturday mornings, it's even worse. So, and I have no idea. Once I get this video created, I don't even know how I'm going to get it uploaded. I'll probably have to drive to Lexington to do that. All right, 2500. Let's go to StatCrunch. Again, blazing fast. Thanks, AT&T. Appreciate your service. All right, gang. Number 4. So it says SAT scores, the population standard deviation. All right. So what we would do there is we would go to a Z1 sample with. I'll tell you what I'm going to do. I'm just going to enter the data here. That's going to be easiest. So 550, 620, 510. Okay, that should be 550. Not be pretty bad. Get a 55 on a SAT score as an SAT score. 720 and 580. Now let me make sure I get those correct. 5 scores. Yeah. So if the population standard deviation is 110, that tells me the population standard deviation is known. So to construct a 95% confidence interval, I have to use Z-stat. If it wasn't known, I'd use T-stat. More about that later. So with that, I'm going to select that. Standard deviation is given again as 110. I think I actually demonstrated this one in class. So to find the margin of error, take 692.42 minus 499.58, divide that by 2, and you get the margin of error. I don't know what it is, but you can get some ownership there and do that. All right, number 5, the mean of a distribution is unknown, but the population standard deviation is 100. If the mean of the 350 represents the first quartile. So guys, what I got to do here is I have to go to calculator, normal, and I have to find the z-score that represents Q1. Well, we know the z-score has mean 0, standard, what distribution of mean z-scores has mean 0, standard deviation 1, and I want the z-score that has 0.25 below it, and that's negative 0.67. So now what I'll do, and again I'm working number 5, I'm going to use the z-score formula. Get it down here where you can. So I'm going to have negative 0.67 must correspond to a score, standard deviation is 100. So guys, cross multiply. I'm not going to do that for you because I think that's something we should all know how to do. Times 100 minus 350, multiply by negative 1, so mu equals 417. All right, a 95% confidence interval for an unknown population mean is 54.2. So I'm working number 6 now. So the interval is 54.2 and 58.4. What are the values of the sample mean, and what was the sample size? Well, guys, the mean resides in the center. So I'm going to go ahead and just get prepared for what I'm going to do next. So I'm going to put 58.4 first and 54.2. It'll become clearer in just a second. So divided by 2. So the mean is the value that resides in the center. Because remember, we take, I'll pretend that's in the center. We take the margin of error to get the right side. Margin of error subtract to get the left side. So the value that's in the center is going to be the point estimate, which in this case is the mean. All right, so we add margin of error to get to 58.4, subtract margin of error to get to 54.2. So guys, the mean is going to be 56.3. Now, guys, remember in these problems, I gave you a formula some time ago that says we can take sigma times z star, quantity squared, over the same difference. But all right, gang, so the value of the standard deviation is equal to 5. We're looking at a 95% confidence interval, so that's going to be 1.96. And the value of the margin of error, well, I need to get that. That's why I did it in this form, because then all I have to do is just come in and make that a subtraction. So my margin of error is 2.1. Put that in your calculator, and I think it comes out to 21 point something. We always round up, so it's going to be 21, or I'm sorry, 22. All right, number 7, the Gallup poll. Let me give it to you. You can pause it and get that. All right. Gallup poll finds that 30% of adults visited a casino in the past 12 months. Data from 1,011 adults is analyzed. What's the probability? Well, probability by now we should know. That we use the normal calculators. So guys, for the distribution of sample proportions, the mean is going to be the value that's provided for the population. In this case, we're talking about all adults, so it'll be 0.30. Here we're going to have 0.3 times 1 minus 0.3 divided by the sample size, which was 1,011. And we want less than 250, but just 250 as a discrete measure makes no sense unless we talk about out of how many. 250 out of 250 means one thing. 250 out of 1,011 means something else. So you have to provide the context, because we have a sample size of 1,011 and 250 out of those is what we're looking at. So guys, the answer would be 0.0001271. All right, B, the data finds that 300 of those sampled construct a confidence interval. I was slightly confused because I noticed a lot of you working on this problem and you used the confidence interval formula. I mean, that's perfectly fine. I mean, there's nothing wrong with that, but I'm going to do things the easy way. I'm going to go to proportion stat with summary, and I'm going to type in 300 there. I'm going to type in 1,011 there, and I'm going to put the confidence interval as 0.95 and then make sure standard walled is selected. So guys, the confidence interval is given right here, 26.9% to 32.5%. I did that problem in about 1/10 of the time using StatCrunch, which you're going to have access to, than if I had used the formula by hand. It's up to you. It's your life. Do whatever you think is best. I like the most efficient way. I feel like I'm going to have less opportunity to make a typo using Stack Crunch than I would, because I'm kind of a bonehead. A lot of times I'll have 23.8 and I'll end up writing it down as 28.3. So it's something. So anyway, I just use the procedure that seems to minimize that type of error. All right, number 8. I'll give you a shot at that. Well, be cool if you could see it. Number 8, 95% confidence interval. What was the sample size used? Well, guys, the very first thing I need to do there is I need to find the margin of error because I know I need that. So 76.5 minus 67.5 divided by 2. So the margin of error is 4.5. So let me get stuff organized. So what was that problem? Number 8. So 4.5 or actually 4.5%, 0.45. Now we know the Z critical here is going to be 1.96 because it's a 95% confidence interval. And I gave you a formula the other day, but let's go ahead and write this out. We know that the margin of error is equal to Z critical times the square root of p hat times 1 minus p hat. The problem we did earlier with this distribution of sample proportions, confidence interval for proportions. This is just, I'm sorry, we did distribution of sample means, confidence interval for means. Same kind of problem. So we know the margin of error here is 0.045. We know that Z critical is 1.96. And we know the p hat, again, we should know by now that p hat resides in the center of the interval. So it's 72%. So 1 minus 0.72, 0.28. If you can't do that in your head, just use your calculator. All right, so guys, I'm going to take 0.045 divided by 1.96. Then I know I need to square both sides. And then I'm going to take 0.72 times 0.28 divided by the answer. Round up, 280 or 383. I'm telling you, man, I am working on absence of coffee this morning, or absence of not enough coffee, and I'm struggling. All right, ACT scores, percentile ranking, and all this stuff. So let's go to StatCrunch and make it happen. So stat calculator, normal. Make this bigger so people on Mars this morning can see it. So the mean is 20.4. Standard deviation 4.8. This actually varies from year to year, but all right. What is the percentile ranking for an ACT of 18? So what I want is the percentage less than 18. So this would be the 31st percentile. What is the IQR? Well, that's really cool because we can just do between. And I want between, and IQR is just the value between the middle, or the range of the middle 50%. So take 23.6 minus 17.2, and you get the IQR. If n equal 10 students are selected, what is the probability that their average ACT is less than 22? Well, guys, nothing changes there except the standard deviation converts to the standard error. And if you're wondering if the sample size of 10 is large enough, it is, because we have a normal distribution. If this was a severely positively skewed distribution, we need to bump our sample size up somewhere around 25, 30, ideally 100, but 25, 30 seems to be a reasonable threshold. So square root of 10, and we want what, less than 22. So I need to go standard again. So less than 22. Let's see, I'm kind of freaking out about that. Let's make sure that is, yeah, all right, so 0.8541 would be the answer to that. Okay, 10 students are selected at random and they have an ACT average score of 22. Let me bump back over here. I got a little place up here that I could write. So the z-score is going to be the average, which is 22, minus the 20.4. And the standard deviation is 4.8. Since we're taking the z-score of an average, not an individual score, we have to, how many people do we have? 10? Okay. We have to use the standard error instead of the standard deviation. I shouldn't do this. This should be something that's pretty obvious to calculate, but I don't want any misunderstandings at this point. So it looks like to me it's 1.05, so the interpretation would be that an average score of 22 for n equal 10 students is 1.05 standard errors above the mean. Number 10, this is a positively skewed distribution. When we have a positively skewed distribution, the preferred measure of center would be the median. The preferred measure of spread would be either the quartiles or IQR. That's just definition. That's something that we've talked about before. Well, I guess technically we've talked about all this before, but the reason is in the presence of outliers, which you typically have, I would estimate that these values right here would probably emerge as outliers. Again, I'd need to depend on a box plot to figure that out, but I would think that those probably, 12 and 13 probably would be outliers, 11 quite possibly, 10, who knows. But again, I could answer that very quickly by constructing a box plot if I had the raw data. So anyway, in the presence of outliers, the most stable measure of center is the median. And when we have the median as the measure of center, the measure of spread that goes with it, always and forever, will be the IQR and or quartiles. Now, if we had a symmetric distribution, something like that, well, the mean and the median are the same, or very close. So we refer to the one that, or if we're looking at a distribution, we'd use X bar. A distribution of sample data if we're looking at a population, and we would have mu. So anyway, then what goes with the standard what goes with the mean? It would be the standard deviation. So either sigma or Sx. All right, enough of that. All right, so student measures the boiling points, yada yada yada. So let's go back to and let's insert that in. 102.5, 101.7, 103.1, all right, 100.9. Let me get this over here where I can see it. 100.5 and 102.2. All right, so 6. Everything look right? Yeah. All right, so calculate and interpret the 95% confidence interval given that a student knows the population standard deviation. Guys, we should be on autopilot now. That if we have the population standard deviation, we're calculating a z interval. So guys, I have my variable z2, standard deviation is 1.2. And we need the 95% confidence interval. All right, so you know, the lower limit is 100, upper limit 102. Okay, so just take the big number minus the small number divided by 2, and you'll get a margin of error plus or minus 0.96. Now, the second part, calculate the 95% confidence interval given that the student has no information about the population's standard deviation, which is typically the case. Well, in this case, you're going to use a t-stat. Select variable 2. Notice that it doesn't give you anywhere to input the population standard deviation because it knows if you're there that you don't have it. So the lower limit is 100.78. The upper value is 102.85. Margin of error is plus or minus 1.07, I think, or 6, something like that. All right. Compare the margin of error. Well, the margin of error is higher for the t interval. Why? Well, the t interval with such a small sample size will have a larger t critical than the z critical of 1.96. The reason is, you know, I demonstrated this in class, as the sample size, when the sample size is smaller, we have a lot more variability in the t distribution. Now, as the sample size gets larger, 100, 250, 500, again, as I demonstrated in class, the t distribution becomes very close to the z distribution. But when you have a small sample size, the difference in the t critical and the z critical is pretty significant. And the t critical is always larger, creating more margin of error. All right, number 12. We want a t critical for the 90% confidence interval. Guys, these are super, super easy if you know what you're doing. So go to the calculator and do t. Go between. Again, let me make this large so people on Venus this morning can see it. So first thing, degrees of freedom. Kind of made a joke. It wasn't really funny, but I made a joke in class that degrees of freedom are extremely difficult to find. They're not. They will become pretty hard to find when we get into other stuff, but right now it's pretty easy. All right, so we went to t critical for 90%, so I would do 0.90, so plus or minus 1.6871 is the t critical. Now, let's say you're on a test and you freak out and you forget about this between button up here. Well, what you would do, degrees of freedom would be the same, but what you would want to do is you would want to find the area over in that left tail. Well, that's just the 90%, 1 minus the 0.9. That's the area under this curve is 1. And I have 90% between two values. So I have 10% missing. Well, I need half of that to go in this tail and half of that to go in this tail. So what I could do is put half of that, 0.10 right there, would be wrong, right? Because that's all of the missing distribution. I need half of that. Now, I could do 0.05 in my head, but I want to make a point here. So then what I would do is compute, and I see I get the same thing. Now, if I want that upper tail, I would want greater than the 0.05, because it's half of the missing distribution. And you see I get the plus of that, the positive. So of the plus and the minus. Once you know one, you know the other one because of symmetry. All right, gang, that's all I got. Got a busy day.